What's up, everybody? This is Ryan here for your daily weather bulletin. It is unseasonably cold where I live. It's like 0 degrees ambient temperature and a wind chill of like -6. So, yeah, it's frickin' cold. But hey, I live in Canada. Welcome to Livestream Programmer, whatever the hell I call this thing, number 7. I've got a fun lesson planned, but what I'll actually type that in here. The lesson will begin at, let's say, on the hour. So, for the next 13 or so minutes, I'll just be rambling a little bit while I wait for people to join. And during that period, I will be interacting with the chat. And then during the lesson, I won't be. And then after that, I will be once again interacting with the chat, because this is a Q&A show. Anyways, I hope you're all doing well. I just thought I would ramble about a couple of topics which are of personal importance before we get into the main lesson. For starters, I had the... well, let me just put it this way. I consider Twitter, the social media platform, to be simultaneously the best and worst social media platform ever created. It's the worst because very often when I go on Twitter, I'm bombarded with really awful things that I really don't want to see. But why I think it's simultaneously the best is that a couple days ago, so I've been studying JavaScript engines and browsers. Before I go into web development, I've done a little bit of work in JavaScript, so I know the basics. Shout out to my friend Jamie Corkhill, who taught me pretty much everything I know so far about JavaScript. But I've been studying JavaScript engines, and one of the topics in JavaScript engines, or engines of any kind in programming, is the topic of what is a compiler versus an interpreter. I had a relative idea what the difference was, but I was trying to figure out some kind of analogy to hopefully explain the difference eventually. So I made a tweet, and I tweeted out to a whole bunch of people who I thought might know a good answer. I don't remember everyone on the list, but I tweeted to Uncle Bob Martin, Robert C. Martin, Brendan Eich, who is the creator of JavaScript, Don Felker, who's just a developer in the community who I have basically looked up to since 2016 when I first started watching him on Fragmented podcast, and Linus Torvalds, and I think that was pretty much it. Maybe there was one more person there. And when you make those sorts of tweets as someone like me who's just like a random no-name software developer and student of programming, you don't really expect to get a response. At least I didn't. And I ended up getting both a response from Brendan Eich and also Uncle Bob. So, ironically, since I've been studying JavaScript engines, it's basically like, the analogy I used is it's kind of like if I was a high school, or more like a college level basketball player, and Michael Jordan just, tweeted back to me or something like that. Because Brendan Eich is the creator of JavaScript, and if you are using a browser right now to view this, which most likely you are, then it's running JavaScript. It has a JavaScript engine. So, anyways, that's just some personal rambling. What's up, Harish, Florian, and Chaitan? How are y'all doing? I'm just going to drink some more coffee. So yeah, that was a cool experience, and I was kind of joking. I think what I'll do is, since I don't have any academic credentials for a resume, what I would do is I would just basically delete everything on my resume except contact details, and then what I would put in there is basically Uncle Bob and Brendan Eich responded to my tweet, and then that would just be my whole resume as a software developer. So, yeah. Anyways. Oh, that's too bad. Chaitan is Sounds like he's sick. Well, that sucks, man. I'm sorry to hear that. Make sure you have some vitamin D and, yeah, I hope it's not the COVID. My whole family is sick as well, except for me somehow. So, I'm not complaining there. We'll see though, it's bloody cold. It's actually, so I actually live in the warmest part of Canada, which is the west coast of Canada. We kind of joke that it's like the Hawaii of Canada. And it is at least 10 degrees, probably more like 12 degrees below the seasonal average temperature. So it's pretty frickin' cold here. All right. So I haven't totally started the show yet, but happy to ramble a little bit. Not sure how to pronounce your name. Lucier asks, I've been studying design patterns and I was wondering if you could make videos about them since I really like them. I have actually made some videos on some design patterns. So there are a couple things in there. Recently I implemented my own version of the observer pattern. I'm not sure if I made a video on that, or I feel like I did talk about it at least in a live stream. And, you know, I talk about the facade and repository patterns all the time. That could be an interesting thing to do, making like a series on design patterns. Not the worst idea. All right, well, I think I will begin the lesson shortly. I might start a few minutes early because I think most of the people who are going to end up joining and watching the lesson are probably here. What's up, Siddharth? I think we have an interesting lesson planned. So let me just do, I'll kind of introduce the lesson and then we'll get into it properly. So as you know, if you've been watching my channel, I kind of hate jargon, and jargon is like technical terms. Words like state is one of the ones we'll be talking about. And why I hate jargon is that we see some common problems with it. Two common problems I see. Number one is that we will have a word like state, as an example, and there will be maybe 5 or 10 different definitions which basically underlie a single word. If we think of this, we're programmers here, it's like having one variable and then 10 different memory spaces depending on which system, or I don't know, kind of a stupid analogy, but hopefully you understand what I mean. The word is not the concept it points to, is what I'm saying here. And then we'll also have 10 words to describe the same concept. In this particular case, one of the words that I've heard a lot in my career, and the primary part of this lesson, one of the primary parts, is the word state. And I knew it had something to do with data, excuse me, but I wasn't actually totally sure what it had to do with data and how is this different and what are data streams. By the way, thank you, Chaitan, for suggesting this particular topic. Get well soon, bro. But the topic comes from him. And we're actually going to be talking about a number of things, and I'm going to try to keep it fairly short and as simple as I can make it. But we're going to be talking about things, and we're going to start in like the lowest level you can get with programming. Then we'll move into like more day-to-day type software development stuff. And then at the end, we're going to look at basically how this affects our entire architecture, or the data streams that run across our architecture like that. So I think this might be a fun, interesting lesson. Many of these things are actually big paradigm shifts in new ways of looking at something, new ways of thinking about something, which I went through in my studies as a software developer, and then also recently I got a lot more into the computer science sort of realm of things and learned some interesting stuff. So I think it'll be a good lesson. Anyways. Alrighty then. So I think we will get started. So what we're gonna do here today, All right, let me just organize things. So again, just for the next 20, hopefully minutes, I'll try to keep this pretty short, but you know me, I talk a lot. That's why I'm here. But I'm not going to be able to look at the comments in the chat for a couple minutes, so I will get back to you, and please do stay tuned, because this, this is hopefully going to be an interesting lesson for you. The main topic for today is what are states, events, and data streams in programming, and I'm going to try and teach particularly this part, the data streams part, in a very practical way. We're not going to use a whole bunch of fancy words. I am going to show some code examples, which I just realized I forgot to pull up, so I better open up Android Studio ahead of time. And I'm just not going to talk because my CPU is going to be slowing down for a minute. Might stutter a little bit, just give me a minute. I have a very powerful computer, as you can probably imagine. That was sarcasm. Okay, cool. So for day-to-day stuff, we're going to focus... I've already talked a lot about events, so we're not going to talk about that very much. I've written a lot of articles, and I talk about this regularly. We're going to focus on data streams in programming, but I also want to talk about this word state, because you'll hear this word when people are talking about data, and in my case I was confused about what it meant and how exactly it was different from data, and I can kind of work this in all together because this idea of data streams applies to both low-level programming, digital circuits even, as we'll see. We're going to focus on the more day-to-day usage of this thing, but I'm going to try and blend a whole bunch of different things together. So, without further rambling, let me just have a big pull of coffee. And it is now time for today's lesson, which is what are states, events, and data streams in programming using simple language, some pictures, and a bit of code. And please understand, down in the description box below, there is a link to an article where I basically explain everything I'm about to tell you in kind of an article format, but I've tried to put together sort of a standalone lesson that we can work with for a more visual... wow, thank you Windows 10 for minimizing every window. What the hell was that? God, I fucking hate this operating system. What the hell was that? Okay. Classic, live lectures for Ryan. Okay, so seriously, I don't know how does that even happen? I did not hit Windows D. All right, so let's get started here. We're going to start with number one, some very low level details here. So what does the word state mean is our first topic of discussion. So what I'm going to do is we're not going to use a whole bunch of words. I'm going to basically... This is a joke, is it not? Why can't I open up my file explorer? What on earth would cause that? Oh boy. Don't worry. We'll get to it. Oh, Windows 10. Okay, here we go. Yeah, definitely going to make a edited pre-recorded version of this. Okay. Windows 10 is incredible. Here we go. So let me just take that from the top. So today we're going to be talking about what are states, events, and data streams in programming. And we're going to start with what does state mean. So a little while ago I built a Minecraft computer. Actually, let me show you the whole computer too. The whole computer, it looks like this. It's a virtual Minecraft computer. We've got all kinds of stuff, like we've got the program counter here, we've got the instruction memory here, the instruction set down here, blah blah blah, technical stuff, accumulator. But we have this thing that kind of circles around everywhere. And this is called an immediate bus. Don't worry, you don't have to memorize any of this. But this photo here is a photo of the immediate bus. And I'm going to have to kind of rearrange all my windows because they got minimized because Windows 10 is garbage. I'm only half kidding. But basically what we have here is, I want you to understand something in particular. We think of, whenever you hear people who do low-level programming, you'll almost always hear them talking about bits, so something that can be on or off. And we'll be talking about zeros and ones, but something that I like to emphasize is that a 0 and a 1, which corresponds to, say, for example here, a wire that is on and a wire that is off. Zeros and ones are how we talk about wires that are on or off. Now, technical point, we don't necessarily have to use wires that are on or off, that have a voltage or not, to basically build a computer. You could actually build it using pipes which push different pressures of water and stuff like that. But it just happens that using wires and electricity just really works well. So what we have here is what I would call a 4-bit immediate bus, which means that there's 4 wires. So let me see if I can manage this. So I want you to keep this in mind. Probably you have some kind of USB device. Like I have a mouse here that has a USB plug. And most USBs, at least, you know, in general, they're 32-bit. And what that means, anytime you hear this, you know, 64-bit, 32-bit, I basically want you to imagine that for 32 bits, you have 32 wires running in parallel, and they're on or off, basically. So that's what that actually means there. So I just wanted to introduce that basic idea about bits and how we're almost always talking about wires or digital circuits, to use the fancy word, which are on or off. Okay, so that's basically part number 1. So next we're going to talk about, okay, well, what does this mean in terms of states? So for a 4-bit, we'll just say component. So when I say component, I'm talking about, you know, anything here. This is like an 8-bit component. This immediate, it's got 8 wires. This is a 4-bit. We're talking about the size of, or the number of wires. So in a 4-bit component, we have 15 states. So what this basically means is we have, what is it? So 4 plus 3 plus 2 plus 1 different combinations, which basically means to say that we have like 15 different ways, combinations for our 4 wires to be on or off, essentially. Where did my image go? Did I accidentally close it? I guess I did. And so basically what I'm trying to say here is that a 4-bit component, and don't worry, we'll get into some high-level stuff in a moment, it can represent the decimal numbers 0 through 15. And for this reason, that means that a 4-bit component has 16 states, 16 different possible, finite, specific, countable configurations. Okay, that's all we're going to talk about with the low-level stuff, and I just wanted to plant that idea here so that what I'm teaching you, hopefully it'll be grounded in something that will give you some confidence about what you're talking about, because I needed to learn this stuff before I really understood what I was talking about. Now we're going to move on. Let me find my notes. So, now, 2. What is data? Now, before I proceed, this is a very generalized word, and I'm going to give you my definition here of what data is. And this isn't necessarily going to be the definition of other people. What I'm doing here is I am prioritizing clarity something I think you'll probably be able to understand over prioritizing a precise technical definition. And the truth is that not everyone has the same precise technical definition, so that's kind of a joke anyways. So when we talk about data, a classic example is something that looks like this. This is pseudocode, but what we're generally talking about is we've got these different pieces of information represented virtually. And again, remember, these are all ultimately just wires that are in various configurations, which is why I wanted to bring that up in the beginning. Now, how is this different from this? How is data different from state, for at least for the purposes of this lesson? Because you'll hear some developers use this quite interchangeably, and I just told you already that ultimately underlying whatever we write here in whatever programming language, we're just talking about ons and offs. So let me share my definition. So, and hopefully this will be useful. And again, I'm going to be going through this kind of quick. All of this stuff is in the article if you want to take notes or stuff like that. So data is effectively the state of some component or group of components. So we could be talking about one individual memory cell or memory latch. We could be talking about a whole database or a whole system. Given meaning. By meaning, at a minimum, I speak of human readable names, so like user ID, language specific types, so for example like int, and optionally a structure of some kind. So here we're talking about a user, to group individual pieces of data together. So we could be talking about a composite data type, or we could be talking about just an individual kind of field or variable or property or whatever you call it in your particular language. Now, again, this is not necessarily the industry standard definition, but this is the way I think about it. Data is something that you, like if you were to imagine you wrote it down in a spreadsheet, you would probably have names for the columns and all those sorts of things. It has an element of human readability. We could get more technical and you can add a lot more things like access modifiers and language specific stuff, but this is generally how I think about this topic. But again, remember, to the computer, this stuff is irrelevant. It's all just another blob of zeros and ones. Okay, so moving on, we're going to get into talk a little bit about what an event. What is an event in computing? We're not going to talk too much about this because I've already talked a lot about it in previous live streams. So again, I'm going to prioritize clarity here and share my own definition. I think of an event as a change at some particular time, and time is an important thing here when we're talking about events. It's a very time bound concept. At some particular time in the state of a running program. And in case you've ever heard the word process before, a process is a running program. That's exactly what that means. And this is pretty much the same across every computer system I've looked into, at least across Unix systems. Okay, now let me see what else we've got for the notes here. So now again, wait, let me just find my place here. So the important thing here is that we can think of a single event and model it as some kind of data type or structure, but we should, and this is where we get into the higher level stuff, we should also think about how an event in one component, and we could be talking about hardware or software, your objects in memory space, an event in one component can cause a flow or stream of changes to the state across various components in the system. Now, hopefully we're starting to connect the dots here, and now we're going to talk about data streams, or we could talk about them as event streams. It's kind of, we're starting to blur the same lines here, and I don't really care to make hard distinctions. Sometimes we just send an event like an enum or something like that, and sometimes that event needs to carry data, whatever. I'm not going to worry about that too much. Okay, so let me just check the chat to make sure people can still see what I'm doing. Okay, cool. All right, so what we're going to do is we're going to look at some examples. So before we get into describing the whole, I've got an infographic for everyone, and I'll walk you through that, and then we'll go through an actual event stream in my code. But I need to point out something technical and specific here before we get started with that. I'm just going to copy and paste this in. So before you dive into event streams, I highly suggest you find a data or function type which is capable of modeling successful or failed operations and interactions or events, however you want to phrase it, with other parts of the system. Let me give you a couple pseudocode examples so that you know exactly what I'm talking about. Depending on your language, we could use a data type, is what I'm going to call this. Is it a data structure? Is it a data type? I don't know. I don't care. Whatever. Called typically I'll call it a result wrapper. And so we've got some kind of type called result, and then we have two children. So this would be like extends in Javaland, or it would just be a beautiful little colon in Kotlin. Whatever language construct you use is what that means. And they basically extend the type. And the reason why we do that is that then when we send this data type through some kind of function or method, all we need to do is we just check what subclass it is, even though we can send it through as just the parent type. And then we can do whatever we need to do based on whether it's, if, let's say result R, we'll just call it R, but that's of type result. If R in, I think Java we use instance of success, then do something, handle it that way. Or if it's an instance of failure, then handle it that way. Whatever, let's move on. We can also use an interface. I did this recently. I created what I called a continuation or callback interface. That looks about like this. We'll see an example of this shortly, so I won't go into too much detail. But we have an interface or protocol or whatever you call it in your language, which has a function this time. Instead of having like a sort of a data type to represent success or failure, you've got a function which represents either one. And then we can, depending on what language you're in, Kotlin, this certainly applies, you could use like a function type. And that's going to look something like this. And again, all of this stuff is in the article with more detail. So if I'm going through this really quickly, just don't worry about it. Look at the article. It's behind a paywall. If you don't want to, if you can't access it, I do have a friend link I can share with you so that you can view it behind the paywall for Medium. So here we have a function type. So this is my pseudocode of saying we're defining a function type, which that should probably be lowercase. It accepts some kind of object or thing, any, whatever. It accepts something. The inner brackets here, they represent a function. And then this is the arguments to the function. And then this is the reference to it. So we have, in Java, I think we call this a method reference. In Kotlin, we just call it a function type. And usually how this will work is, we'll do something here, // ... make a call to the database or network, whatever. And if did something and it didn't fail, then we invoke that particular function with the data or an error. In Kotlin, I'll probably switch to doing this most of the time because this is kind of cool. I like this. So I just wanted to get that out of the way before we dive. We're going to go right into data and event streams now, but I just wanted to point this out. This is how you connect your event streams together, your different components together into an event stream. A side note, which I talk about in the article, you will probably want some kind of concurrency framework or library. And again, this is language specific information, but it could be coroutines, it could be threads, it could be, what do they call that in Java, future. I don't really care, but the point is what we're passing through this concurrency tool is some kind of object which can represent success or fail, or more things. There's more things you could represent, which we'll look at later. Okay, moving on, let's get into the big picture. And luckily, I actually have a big picture for you, which I will pull up now. So what are event streams? Well, a couple years ago, I was working with RxJava, which is a big, scary reactive extensions library, which some people say is a great way to write spaghetti code, and some people say it's a really great way to handle concurrency and write functional code. I'm not saying that's my opinion either way, but it's a very powerful and expansive library, and it's complicated. In trying to understand this in my own way, and generally I best understand things visually, this image popped up into my head. I've showed it before. I might actually show let me show the original image. This will be something extra which you didn't see in the, which I don't share in the article, but this kind of image popped into my head of event streams and what they kind of look like. Anyways, we're not going to talk about that. So I want you to imagine, and we'll go through a code example here, that in the user interface or just from the system, in the kind of code I'm used to writing, the view will tell once it's set up, the decision maker, which could be a presenter, controller, view model, or whatever, it'll usually say, hey, I'm ready for you to start getting the data. And so it'll send a message. But this could also come from like the system. It depends on your platform and what you're building. But basically, if we have some kind of basic architecture, view, logic, data stuff, basically. So the decision maker will send a request to some I/O device or a set of I/O devices. It'll be like a cloud storage or disk storage or system service. We'll see an example of what I mean in a moment. And these kinds of operations, we can almost always model them as success or failure. And that's generally what we might have the I/O device return, or maybe the decision maker will create that thing. But we see this flow of data or flow of method calls, both actually. So we send a request, the I/O device, asks the, you could kind of think of this as a repository, but the I/O device tries to get the data, and it'll return a result to the decision maker like we saw before. And then the decision maker will handle that result, and it will say to the user interface, hey, here's the data to draw for the user. Or, hey, something went wrong, tell the user about that. So what I'm trying to show you here is just a very simple example of data streams and their nature of forking. They fork into different sets of events, different states, different possibilities, depending on what's happened. So we're going to look at a code example of this really quickly. Here we have my day planner application. I will be converting this to Kotlin shortly, so don't worry if you're not a Java fan. So we're going to open up day view. We'll open up logic, and we'll kind of skip the repository interface stuff today, but we'll have day storage and task storage. Okay, so I kind of want you to keep this picture in mind if you can. So we've got the view, the decision maker class, the backend thing, and I want you to kind of keep this flow in mind, and I'll show you what it looks like. And you know, like I said before, there's different ways to do this. This is a Java specific example, but hopefully you can imagine something in your own preferred programming language. So we have our day view, which is like our user interface. And what it does is when we hit this certain lifecycle method, it says to the logic class, hey, onStart, go get the data. So this, of course, represents this thing here. We can set it up ahead of time to have a loading screen as the default state, just a little tip there. And then we go into the logic class, and then this thing handles that event. Okay, and we go into onStart. And then here we're asking our backend thing, our I/O device here. We request something. We send a request to it. And then what will happen is we go into day storage. Where is the thing? It does what it needs to do, and we won't talk about concurrency, but this needs to get deleted. That's just a little example code there. It does what it needs to do. It you know, asks the file system in this case for the data. Cool, we're happy. And then depending on what happens, it'll either say that was a successful operation, or if there's an exception thrown, an error, it will tell the front end or the decision maker class about the result. And then that will pop up here on success, on exception. Now, sometimes we have situations where we need to call multiple different data sources. So we have, this is actually a better example here. Sometimes in a single event stream, we need to call multiple different backend services, or whatever you want to call them. Maybe we need to check if the internet is connected first, and then we need to check if the data is present in the remote cloud storage. So then we see, all right, so if on success we go into get tasks, which is down here, we do exactly the same thing. And then if that is successful, then we, again, will do bind data, which is equivalent to this thing here, show the data. Or if either of these fail, then we show a message, generic error message. Obviously, this needs a little bit of work. It's just like a demo app. Then we handle that appropriately. So this is how I think of data streams. So what I was going to do, I was going to talk about, I was going to share a little bit of an example where I show you how I model these data streams. And I don't think I'm going to do that because I think I've talked for long enough, and we'll get into some Q&A stuff. But if you want to learn how I model these data streams, I had an example ready to go in Space Notes, and basically just I'll show you really quickly. We won't go through the whole thing. Write a basic definition of your event stream. So here we have like on, done, click, and then label each fork. I keep closing that old picture when I should have it open. Label each fork. Okay, hopefully you know what I mean. With like a letter A. Label each sort of fork in the event stream, and then basically write a test for every fork in the event stream. And if you can do all of those things, then I think you'll have an easier time designing and testing and connecting the different parts of your application components together. But with that being said, it's not easy. It took me a lot of months to kind of figure out how to actually do this. And so, yeah, it's, I'm not trying to make it sound easier than it is. So that is my lesson, my rambling on event streams, state, data, what all these things mean, and how we can kind of connect them together from low level, mid level, and software architectural perspectives. I'm going to catch my breath, drink some coffee, and then we will get into the Q&A. Okay, so I'll just have a look in the chat, and yeah. Well, Florian, if you ever do decide to do a podcast, let me know. I feel you, though. My PC is pretty damn old, too. Florian says, I had to put it on the other side of the room because it's so loud, his PC. Yeah, I had that same problem for a lot of years, and it sucks. What's up, Jesu, or Jesu? Luthier asks, is this code available? Are you talking about the, where did it go? Are you talking about this particular project or the pseudo code I showed you in the lesson? Because the pseudo code is available in the article. I haven't published this repository yet, but I probably will. I'm close. This is basically almost like the final version of the Java version of this. Oh, okay. Yeah, I haven't posted it publicly, but I do have a video, a live stream recently where I overview this entire project. I will eventually share the source code, but let me just pull that video link up. And while I'm doing that, does anyone have any questions? Okay. This video, it's a long video and it's live, but I did timestamps for it, so it basically overviews the whole architecture and everything worth talking about in this particular project. And so yeah. Anyways. Yep. Yeah, I'm looking forward to a Kotlin migration. Well, we've got let's just dive in here. Okay, let me just, there we go. Maybe I'll put my face back on. There we go. Okay, so, Luthier, not sure how to pronounce that, asks, I have in my code the view model, a reference to the logic class. Is that okay, or do I have to put them separately? Let me pull up a diagram. Now, when I say this, well, I'll talk about how I would do it, and then I'll kind of talk about why I try not to be too dogmatic, and I kind of try to emphasize that if it works for you and it doesn't break any major principles, it's probably fine. Where the hell did I... All right, here we go. Okay, so this is my model view, whatever, I don't care architecture. And as you can see here, so this is how I personally like to arrange. Let's say I have an application where I'm not really comfortable with just, model view, view model or model view presenter. I feel like I need a logic class in there instead of filling the view or the view model full of logic. And I see a lot of people doing that, and it's okay in smaller projects, but if we're being really extreme about separation of concerns, it's technically, not proper, but yeah. I personally think that the presenter should have a reference to the view model, and the view should observe the view model. I don't really like having the view model tell the logic class what to do. But with that being said, the problem with ModelViewModel is that there really isn't one way to do it. If you've been watching my channel in the past like 3 years or 2 years at least, I've been rambling about this for like literally years. It depends. Some people actually use their view model as a logic class, and in that case, you're going to find logic in it. Maybe I can look at some examples here about how I use it. Let's open up day view model. Now, one point about this application, I figured out a way to actually implement the observer pattern or the publisher subscriber pattern to hook up the view to the view model, which didn't use live data. And you'll notice my view model doesn't use Android architecture view model. Again, I don't mind. I would say that view model from Android Jetpack is one of the few libraries in that whole thing that I still like. Oh, I just had a light go out. But I don't typically use a lot of third-party libraries. So what I would prefer to see is that if you have something called a view model, it implies that it stores the data necessary, the data or model necessary to draw the view. In my mind, that should be something that basically just stores data. Front-end session data is what I typically call it. And then the view should be observing that, and then it should bind whenever that thing gets updated. We're having some light, little light show here. So yeah, that's kind of how I think about it. And just trying to think. So in my logic class here, which is basically a presenter, I update the view and I update the view model. This is slightly suboptimal, and let me open up how I want to do this nowadays, although I didn't want to do this in Java because I'm switching back to Kotlin shortly, and Java is just pretty friggin' annoying to write in many ways. But let me just show you how this works here. Sorry, Gradle is building, so I'm just going to wait for a minute. Oh. The stream gets all laggy. Still building. Okay, I think we're ready. Hopefully I'm not stuttering. And by stuttering, I mean the live stream, not myself, although I do stutter on rare occasion. Okay, so how I prefer to set this thing up is so basically this is what I'm going to show you here is what I show you here, is this picture. This is a high-level abstract, version of this particular thing. So our view model is a publisher. This is a pattern. Someone asked me earlier about design patterns. Here's an example. Publisher and subscriber. And this is also known as the observer pattern. Same pattern, basically. Some people argue that it's slightly different, and when I actually looked into the differences, it's like, yeah, it's the same pattern, basically. It's not worth arguing over. So the publisher subscriber pattern I demonstrate using this eyeball with an arrow. So this is the subscriber or the observer. This is the publisher or the observable. There's many other ways you can talk about that. Subject and object or some bullshit like that. But yeah, so that's what we're talking about here. So as you can see, my view model is a publisher. And what that means is it has a list of subscribers. And anytime I update something, like these things represent user interface widgets, every time I update them, and the logic class, if I can find it, will update the view model. And then what happens is by updating the view model, the logic class will indirectly update the view. Now, sometimes the logic class does still need to talk to the view, and that's okay. We don't want to draw an arrow from view model to view. That's bad. And the view can communicate to the logic class, but we get this kind of system. So the view says, hey, logic class, hey, dummy, it's time for you to look up some data. The logic class says, well, you're a lot dumber than I am, but okay, I'll look up the data. It gets the data, it updates the view model, and then by extension, it updates the view. That's kind of how I like to, in a perfect world, model these things. And this is a very decoupled, clean architecture for GUI applications. And that's kind of how I like to share this. I think I did share this particular repository. And what's up, Harsh? Yeah, so I don't know if I answered your question. I kind of went off on a tangent there, but I just wanted to show you what I'm talking about here. Again, reminder, this is a Q&A. Feel free to ask questions. I get this question now every live stream. Why Java, sir? Well, sir, because I had to write in Java for about a year, even though I'm really good with Kotlin, and now I'm about to be transitioning back to Kotlin. I do think Kotlin is a better language overall, but because both of them, at least in terms of the Android platform, compile to the Java virtual machine, becoming a better Java developer will definitely help you become a better Kotlin developer. It's less so the other way around, but in a way, learning Kotlin will, help you a bit in learning Java. Certainly the libraries, because when you're working with Kotlin on Android, because there is a multi-stage compilation process where your Kotlin code gets fed through both the Kotlin compiler and the Java compiler, you can use them interchangeably. There's high interoperability. So hopefully that kind of answers your question. So Lucia asks, so is it okay for the logic to update the view? Yeah, that's fine. Let me show you classic. Let me show you a classic diagram here somewhere. Je ne sais pas où il est. Oh, come on. Where's the real one? Sure, I had a friggin' diagram for this somewhere. I have too many diagrams. I have the best diagrams. Okay, whatever. I'll just show you the one that will demonstrate what I'm trying to say. So just ignore the words fake and real. Just pretend these are all real things. In classic Model View Presenter, am I in the right mode? No, I'm not. Sorry. In classic Model View Presenter, you will have an arrow, and an arrow, you have to understand, this means a reference or a dependency. So this arrow here from the presenter to the view in this application is a representation of this reference here. Now I'm using an interface, but whatever, that's technical details. Let's stay on track here. We're talking about arrows meaning references. These are ways that these different software entities can communicate with each other. In classic Model View Presenter, you are allowed to, and you have to draw an arrow from the presenter to the view and vice versa. You could set up that relationship I showed you before, the publisher-subscriber thing, but I don't really find that super useful or necessary if we're doing Model View Presenter, to be honest. You're kind of getting into the territory of it actually being Model View View Model. So, because remember, these are words, and the patterns themselves are things that arise in the code, and we very often mistake the words for the patterns themselves. So, to answer your question, yes, it's in classic Model View Presenter, and also in my style of clean architecture. It's okay to have an arrow that goes to the view from the logic class. It's never okay in basically any version of ModelViewModel architecture to have an arrow that goes from the view model to have a reference from a view model to a view. This is especially important if you use view model from Android architecture components or Jetpack or whatever the hell it's called, because you will get memory leaks. So that's especially important in that case. But it is also a general principle of the architecture. All right. Okay, I will try and answer this question. I'll be honest, I haven't really written any Kotlin code in probably a year, but I will try. My bro Chetan asks, sorry, one of these days I will get your name properly. Chetan asks, I'm digging into Kotlin properties at a language level. Is get and set function are also operators? Because I see property delegates, overrides, get value, set value operators. I'm trying to parse this question at a language level. You know, I can't answer that because I don't actually have a strict definition of operator. To be honest, I feel like it depends on what language you are compiling to. Now, generally that will be the JVM. When we decompile the getters and the properties, if it's been a while since I've done this, but I believe we see under the hood functions, not operators. But to actually answer your question specifically, I'm just so out of practice with Kotlin that I don't think I could give you a good technical answer here. Generally, what I try to do in Kotlin is anytime I'm confused about something, I will decompile the code and see how it maps to JVM bytecode. I don't really even have a project open that I could mess around with. But let's see here. Oh, wow. Is that Gabor Zwinden? Damn, I feel it's like celebrities from Android are watching my channel. I feel so blessed. And looks like we have the answer, operator function. Thanks for joining. I like your work, man. Anyways. Yeah, I do suggest, Chetan, have you done decompilation? Let me open up, if you haven't, well, I'll just show everyone how to do this in Android Studio while we're here. If I can find a project that was actually written in Kotlin. My computer will lag for a minute. Just give me a moment. All right. Oh no, Gradle is downloading things. This could take a little while. Fastest build system in the West. Gradle, bring in the noise. Okay. I'm assuming I'm lagging right now, which is why I'm not talking. This is the reality of running a live show on a mid-range PC that is 3 years old, I think. Felurian. That sounds like the name of a spaceship. The Felurian. Oh man, this is taking so friggin' long. I definitely picked the wrong friggin' project to open here. Okay, are we back? Oh, I look like I'm still lagging. Ay, blin. Okay, let me just... Okay, okay. Oh, we might be ready. Best demo ever. Okay, let me open up a data model. Where are we here? Okay, where are my data models? All right, this is a complex multi-module project, so my data models are in the domain module. By the way, side note, Android multi-module, generally speaking, not worth it. I don't really do it anymore unless I would be building a multi-platform application, because the configuration required for Gradle Android multi-module projects, if you don't actually need that level of abstraction, is just totally not worth it. Okay, so when we want to unpack the magic of Kotlin, then we can go to, what do we do? Tools, Kotlin, show Kotlin bytecode, and then it'll generate the JVM bytecode, but nobody wants to read that, except some like serious nerds like me. But we can look at, we can decompile the code. We hit that decompile button, and then we see what our Kotlin code looks like in decompiled Java. And to the point of these properties here, what we can do is we can see that, let's look at creation date. So here we have creation date, and we see getters and setters that are public. And this is, of course, that'll be the constructor. And the way that it does some of this stuff is pretty technical and interesting. But yeah, so we do see that the properties basically work out to being getters and setters, and also private final fields within the JVM bytecode. So hopefully that kind of answers that question, even though it took like 10 minutes to answer it, because Gradle and Android Studio are lightning fast. So just some context. Okay, so let me get to, sorry, I'm just going to address a comment from Gabor. The trick is that the data domain presentation top-level Gradle modules are generally considered to be an anti-pattern, which is why features tend to spread across 3 modules. Yeah, I can attest to it being kind of an anti-pattern. So Gabor, are you suggesting to use a feature-specific setup? Or yeah, I understand. I think I understand what you're saying, and that was my experience with it, which is that if you there's a way you can set it up which requires the app module. Oh, that stupid Android view. Show me the actual files. Gotta hate that default Android perspective in the Project Explorer. It's just garbage. There's a way you can kind of set it up where you have, for example, the front end module depending on the back end module, Everything depends on the domain module, and sometimes I used to have a common module which the domain module depended on, and all these sorts of things. This is an annoying thing, which is that the reason why I have to have my front end depending on the data module is because my particular setup for dependency injection is located in the front end. And let me show you the service locator stuff here. Am I in the right thing here? Build logic, yes. In order to actually build these things properly, I need to have references to the things that existed in the backend. So it almost took the entire point of abstracting out the backend from the front end. It almost kind of removes the actual abstraction that's going on. Now, I can still hide the backend stuff from everything else in my front end module, but it still has to be here. So that was, kind of annoying. Anyways, so let's go to a question from Prashant. I think I can hopefully share some perspectives here. So Prashant asks, is it okay to inject application context in use cases in the domain layer? Almost certainly not. I don't think you will find anyone who, actually writes a domain layer who is comfortable adding basically a platform specific library, part of the Android SDK, into a domain layer. Now, I'm always hesitant because I don't want to make it sound like I'm the absolute expert in clean architecture. Let me share my understanding of clean architecture, and in particular domain layers or packages, and how I design them and how I hear most people explain them. Because there's a major issue with you're actually basically going against the very idea of a domain layer, in my understanding. So let me share at least part of that understanding. Now, here's the thing. I'm going to show you, we're not going to look at a domain module. The same principle applies whether we're doing multi-module or we just have a domain package. We're going to look at just a domain package in a simpler application, and hopefully that'll be easier for everyone to follow. So let me pull that up now. So in this project here, it's just a single module because it's not that complicated of an app. I don't need a whole lot of abstraction here. But we have this domain package, which we could be talking about when we say domain layer, it could be a package, it could be a single file, it could be a module, but we're talking about the domain. You will never find any code in these things apart from standard library. So we could be talking about the Kotlin standard library, or we could be talking about the Java standard library. We can include other data types that we have built from standard library components. Like here we see the day has a collection of hours, the hour has a collection of quarter hours, but if you look at the import statements from all of these things, you will not see anything but language standard library specific code. So why do we do that? So in my opinion, the purpose of a domain layer and the classes in it are to create the most framework and platform independent code as possible. After you establish this very, a word we like to use in English, vanilla, like plain, nothing else added to it, set of foundational classes, enums, and interfaces, or just abstractions in general. Let me scroll down a little. After you establish this domain layer, then you can map to platform or framework specific classes. So this would be like, let me show you an example from the more complicated app. You'll see that in the domain layer, I have these domain models, note, for example, and this is just a plain old Kotlin class, plain old Java class. I also have repository interfaces for the backend. I define them in my domain layer, but we don't have, again, we've only got Kotlin standard library and anything else that's defined in the domain layer. Now, how does that actually look when we need to use these things in the backend? When I open up this data module, we'll see two things. We'll see many things, but for the purposes of what I'm talking about here, we will see the implementations of those interfaces. So here we have the backend stuff implementing the domain repositories. So that's the separation there. Domain layer, use cases, domain models, repository interfaces, and then we have the implementations in the data layer, or we can also think of that for the front end layer. How I love to do this in Kotlin is if you're going to do this, you're going to have to write a whole bunch of mapping logic. And Kotlin extension functions, unless they've become obsolete now, I think Florian mentioned this, that they're changing how extension functions worked, and or extensions in general, and I need to look into this, but at least how I used to do this is that we would have our domain model, and then for every specific data source, so here I'm using Firestore and Room, then we would have the, we would map to a, how can I say this, a data, a framework or library specific data model is what I'll call it. So what's an example here? So I have here a room note. So here we have our room stuff, our annotations. I don't want to see any of that stuff in your domain layer, because to be honest, I don't know anyone who would, who really knows about clean architecture who would do that. Maybe there is someone out there. But this is basically how I suggest. And with Kotlin, you just write an extension function, and then it makes it super easy in your data source. We'll just call, for example, here we're taking in a result from a Firebase call, and then we're mapping it to our domain model. So that's what we see in here. And we can do that vice versa. So anyways, to return to the question itself, is it okay to inject application context in the use cases in the domain layer? Almost certainly not. If you need to inject context into the data sources / repository interfaces, which live in the data package or layer or whatever you want to call it, but keep that stuff out of the use cases. This is a huge topic, and I could ramble for hours about this, but I hope this answers your question. Okay, anyways. Danette says, quick thanks for your videos. They helped me with setting up my app structure. I was wondering what your opinion about view models and Google's view of view models. Well, okay, so I'll try to answer this. So let me actually let's have a bit of context here. And Prashant says, thanks, I will inject into the repository. That's what you do, man. Inject into the backend. Uncle Bob actually says that you shouldn't use any dependency injection framework in your domain layer. That might be an extreme opinion, but I tend to agree. Okay. Anyways, so what is your opinion about view models and Google's view of view models? Well, here's the truth about this. In a podcast with, I believe it was Chet Haas, I call him Chet the Boss Haas, and Yeet Boyar, I believe it was these two. I know Chet was there. They actually openly admitted that when they looked into MVVM architecture, that they did not find a single way to implement it. Or let me be a little more technically careful here. They did not find a single architectural pattern. I misspelled that. Architectural pattern. Now, this is the truth. This goes beyond my opinion or me pretending to know what the Google company's broad opinion about view models is. They admit that there's not a single way to do this. If you want me to, I can go into the details there. It's something I basically talk about almost every live stream. Let me just link an article for people who do want to basically hear my opinions. This article explains two primary versions of, and this isn't behind the Medium paywall, two primary versions. So just in like 2 minutes here, the one common thing we see in every model view model architecture is you're not allowed to reference a view from a view model. That is fixed. But then it breaks down into what I like to call two approaches, but there's more than two approaches. There can be a mixture. But the first approach prioritizes reusability of the view models by not referencing a specific, the presentation details of a specific view. Again, we're never allowed to reference it directly, but by not containing the details. So that would be a view model that just basically exposes some kind of data model. And then the other way we can do this, I like to call it humble view, control freak view model. In this case, the view model actually possesses a field for every widget in the view, and then the view still observes this. And this is more of the pattern that we see in that project that I just closed recently. So I'm not going to open it again and risk having to wait 15 minutes. But yeah, so just a little point on that. So to return to the question, it's not really so much about my view and their view. The engineers are aware that there's different ways to do it. And I actually, to be honest, kind of wish that they had spent more time emphasizing it, because what we see is we see a lot of people getting into arguments about something which isn't actually fixed. And there's a lot of confusion that gets caused about that. And we get this weird thing where you either get pushed into filling your view full of logic, which is counter to the entire purpose of a decoupled architecture, or we get a view model that is full of logic. And then I start to wonder, well, why are we calling it a view model if it's full of logic? Isn't that a stupid name for it? So that's my perspective. Anyways. Yeah, something called a view model, but it's full of logic. That's kind of strange. Now, again, I'm not shitting on the pattern. I'm just talking about, how we talk about it, basically. Let me drink some coffee and we'll carry on. Okay. Prashant asked, please make a course or stream about Android room migration. There's literally no material for this on the internet. I'm sorry, man, but over time, I care less and less about rapidly changing frameworks and libraries like Room. I do like Room, but I've never done a database migration with Room in my own personal experience or day-to-day work, and it's not something I just care to do. I try to talk more about general stuff these days. What else have we got? So Ravi, did you by any chance have had a look at Greenbot Event Bus Library? Basically a single bus for events, but it was really cool, solved a lot of problems for me in the early days. Also, events in present day state management seems a little too much to be worrying about maintaining. And then there's some discussion about Event Bus. So to answer your question specifically, so for Ravi, I haven't had a look at Greenbot Event Bus Library. Now, let me answer the related question that, so Prashant says, Event Bus is frowned upon in general for conservative coding community. And then Ravi asks, yes, but why? Let me explain the rationale, why you have, what is the potential, and understand this is a potential problem. Gabor mentioned this. You can use it appropriately, but you have to be careful how you do this. What is the potential problem that can arise from using Event Bus? So in order to explain this problem, there's a big scary word that we need to talk about, and that big scary word is shared mutable state. And this big scary word means shared changeable data. Now let me pull up an image to describe what we're talking about here. Let me find the image. Okay, here we go. Now, we need to, let me get out of camhor mode. Okay, so the problem is rooted in imperative programming. So this isn't actually an issue in a pure functional programming language, but there are almost no pure functional programming languages. I think Haskell is there, but the hilarious thing about Haskell nerds is that even they eventually do have to have side effects in their code, and then they wrap it in an IO monad, but just ignore everything I just said there. And don't even worry about nailing down a definition of imperative programming. What is shared mutable state? So what I want you to think about is, so imagine runtime, the runtime of a program, like I show here. Sorry, my face is blocking that arrow, but just believe me, this is runtime occurring in a particular direction. Now, shared mutable state is when we have a situation when multiple different software entities, so we could be talking about different functions, we could be talking about different classes or objects. We have these different things basically sharing some data container like an event bus. So I just want you to internally think of this box here as saying event bus. We get into a situation when we have these different things able to modify a shared changeable data store. We can get into these ugly situations, which there's a couple things, but really the root problem is race conditions. So this doesn't have anything to do with racism. What we're talking about is when different software entities and their commands. This is what imperative means. An imperative is a command. Update data, that's what an imperative statement is. When different software entities and their commands compete to update some shared data, and this can cause unexpected problems in asynchronous programs. So let me explain this with a high-level example first, and then we'll go into the specifics about event bus. And again, reminder, it's a potential problem. It's not a guaranteed problem. So imagine we have client application A and client application B, and then we have one server which we'll call C. Now, let's imagine a banking application. So server C is a bank application. Probably everyone listening to this, you have your online banking system. And I want you to imagine that client application, or let's just say client A for brevity's sake, you log into your bank application. Client B is your financial advisor. Or this could be just some hacker, but you know, this example of having like a financial advisor, someone who is allowed to access your data, also logs into, let's be a little more specific, logs into, or okay, we'll say logs into / starts a session with server C. And same thing for your financial advisor. Now, all of a sudden we're in this situation where, in this case, the server is the shared mutable state, and then the client A and client B are the things that are allowed to modify that state. So let's say, for example, I'm trying to think of a clear example here. You pull a record and you pull a record and want to fill out a form, like a web form, to make some change. Okay, and then same thing happens. All right, same thing happens with your advisor. So your advisor pulls a copy of the data, and then you make some change to the data, and then you submit your form, and then your advisor also submits a form, but they submit from an old copy of the data. This can cause problems with the integrity of the data, and it leads to what I said before, race conditions. Different software entities and their commands competing to update some kind of shared data. So I thought that was just worth exploring for a minute. Now let's talk about, let's returning to event bus. At its core, an event bus is shared mutable state. Now, I guess it depends a bit on the implementation. I haven't looked at this one you're talking about in particular, the, what's it called, green bot? Yeah, whatever. But at least the event bus that I looked into last time, it is effectively an event bus is a mechanism for shared mutable state. And the thing about this is that sometimes it's useful to have this problem of shared mutable state, because this is how you could do something like communicating data across different activities frameworks or other components. This is what the event bus can do for you depending on how you use it. Now, if you know what you are doing, then you can protect your code from race conditions even if you are using what is essentially a mechanism for shared mutable state. People have been writing imperative style programs in C language for a lot of years, and there are things you can do going low level. We have like concurrency primitives. We have in Java and probably Kotlin by extension synchronized, and what's the other one? Atomic. It's been a while since I looked into this, but we have the, I can actually show you. In Java, we have operators like synchronized. Maybe that's not the right place to put it, but we actually do have features in our code to deal with these things. I'm not going to give a whole lesson on these sorts of access controls and concurrency primitives. But what I'm trying to say here is that here's how I would say it. The original question is, why is event bus frowned upon? In my opinion, it's frowned upon because if you do it wrong, you can have problems with shared mutable state. But if you know what you're doing and you're a good programmer and you're aware of what these problems are and the situations which can lead to the problems, and you protect your code from those problems, then using event bus is totally fine. That was a lot of talking. I hope I answered your question. Okay. All right. Anything else? Ravi talks about view models as well. You'll see the Android team, they're actually encouraging sharing view models across multiple different activities and fragments, and that is actually basically using it like an event bus in a sense. It's the same problem. But again, if you do it properly, it's fine. If you do it poorly, then you're going to have problems. Ravi asks, if we fail to deal with the problems with shared mutable state, can we run into memory leaks and applications not responsive? I think that's kind of a separate issue. I think you can have problems with shared mutable state and not necessarily have a memory leak. With that being said, again, this is implementation specific, but if you're like passing an application context as opposed to like if you're passing an activity context into an event bus, then you could definitely get memory leaks there. Or if you're passing in a view model or something like that. Anytime you're dealing with a activity specific view hierarchy, that would be when you want to really watch out for memory leaks. I think if you were passing in the application context, I don't know why you would do that, but probably I would imagine the event bus probably does that under the hood anyways, depending on how it's done. So, yeah. Okay, folks. We're an hour and a half in. I still have a bit of energy, so if we have any more questions, I'm happy to try and share. And if anyone has any comments about or criticisms or anything like that, I know I sit here and maybe try and give off the impression that I know everything. I really don't. And if anything I said is wrong, I'm quite happy to hear from you, or different opinions or comments or anything like that. I have to play a role here, which is a presenter and an entertainer. And part of doing that means I have to believe my own bullshit. But at the same time, it's always in the back of my head that I am a student of programming. And I treat all of you as both my students and my teachers. So, yeah, just thought I would mention that. Especially when we have people like Gabor and Florian and people who are good developers, and Chaitan. I'm just trying to do the best I can as a presenter. But yeah, do we have any questions? Ich möchte wissen, was hast du etwas Fragen? Just practicing my German. Ravi has some Flutter-specific complaints. I, for one, have not yet jumped on the Flutter train, and I don't expect to, but it's possible. I just jumped on the JavaScript train, though. I'll still be doing Kotlin for Android, though. I looked into several multi-platform options for doing web and web and Android, and they basically all suck from what I can see. So I'm just going to do web separately, and I'll do Android separately. Well, this is fun. Everyone gets to sit here and listen to me drinking coffee. I don't really have anything else to talk about. For those who have just joined, I gave a lesson on states, events, and data streams in programming and how to visualize them, and I showed you a whole bunch of diagrams, super high budget diagrams, and yeah, hopefully that was okay. I just gotta share this. Prashant says, yeah, Flutter sucks. Ex-Flutter dev of 2 years. Wow, that's extreme. That isn't necessarily my opinion, but I haven't actually used Flutter, so I can either confirm or deny that it sucks. I do know some developers who are very great developers who use Flutter. I'm personally not really bought into it as being the thing that will supplant every other option, because I just don't really see the interoperability of it being any better than what I saw with Kotlin's interoperability. And yeah, Florian says, isn't that coffee cold by now? My friend, it was cold an hour ago. But hey, it still gets the job done. All right, folks, any more questions? I'll close the stream down in a couple minutes if I don't get any more questions, and that's totally fine. We talked about lots of interesting stuff, and really happy. Thank you, Florian and Chaitan and Gabor, for stopping by. It's really nice to get some perspective from developers who are more knowledgeable than I am in many respects. Gabor mentions, sorry, I guess it's pronounced Gabor. Gabor mentions they've added the navigation, or wait, yeah, they've worked in some of the navigation library, if I'm not misunderstanding the comment, into Flutter, so that's good. I maybe start to use the navigation library again. I basically have been boycotting it for about 2 years because I didn't think it was actually any benefit over not using it. It just seemed like a whole bunch of extra configuration for not much benefit. But now that they have conditional navigation and deep links and safe args, those were some features that I did kind of like. Gabor, if I'm pronouncing that correctly, asks, do I intend to update the Space Notes repo? Excuse me. I'm not sure. I'm going to be building what will be a multi-module Kotlin Android project again, which will be actually the first application I ever wrote in 2014. Like actual application, was a workout logging software. I'm going to be rebuilding that in November, and that will be probably Kotlin multi-module. So probably that will be how I sort of reintroduce myself and the few people who care to look at my code into Kotlin. This repository that Gabor is talking about here, where did it go? I thought I had it open. All right, I had it in here. This is a pretty old repository, and not only have I grown as a developer since then, but the Kotlin language has changed significantly. So there's a lot of there's some, kind of best practices in here, which is why I still keep the project up. But I probably should update it to the latest Kotlin, versions and so forth, because I'm sure there's some deprecated stuff in here. But as far as doing too much more with it, I'm not sure that I will. Prashant asks, why is my screen black in color? Is my screen black in color? Oh, my green screen. Oh, yeah, pretty much to answer that, this isn't really a green screen. I'm just hiding the mess behind. I would like to set up a green screen eventually, though, so that I can do these talks from outer space or something cool like that. Dude, that'd be awesome. Okay. Sure, Luthier, I will publish it soon. I'm debating on whether or not to refactor it so that I actually use this architecture. That I talked about here, because it doesn't currently use this little clean GUI architecture. I probably will not do that, but yeah, I will at some point share this repository. I don't like sharing my demo repositories too early, because then people will fork them, and that can be kind of problematic if I end up changing how I do things. But yeah. Let's do one more question, and then I think I will call it today. Gabor asks, do you by any chance intend to replace the service locator pattern with, for example, dagger hilt? Well, I have very mixed feelings on that. So one of the things is that because about half of what I do is teaching, I've lately been more and more avoiding having any particular frameworks, unless I do have user interface frameworks, view-specific frameworks. I've gotten really quite comfortable writing my own service locators and dependency injection implementations without any frameworks. But the reality of that situation is that I am sympathetic to the idea that as the scale and complexity of a project grows, then doing what I do in these demo projects, like writing my own little, I like to call it build logic, my own little injectors which is effectively what dagger hilt type stuff does. And then also, if I need to, having service locators to abstract out the services from that particular thing. I'm pretty comfortable doing this in smaller applications. And of course, I did do that in Space Notes here. I think I called them something stupid. What did I call them? Well, I used a slightly different thing here. Got some Kotlin. I don't even know if this is deprecated now. Delegates by date by lazy. But anyways, the point I was getting to, I am sympathetic to the idea that using a framework like Dagger or Hilt in a small application, unless you're learning how to use it, isn't very useful. I find it pointless in comparison to writing my own handwritten dependency injection. But as the scale and complexity of a project grows, doing it by hand does actually reach a point where that is more labor than using a framework like Hilt. I am interested in Dagger Hilt, and I may end up using that in my new project Catalyst. I'm going to have a very restricted and deliberate set of libraries that I use, and I will look into that one. So it's basically it's a definite maybe. I'll ask Gabor, how do you find Dagger Hilt? Is that something you use quite a lot? Because I haven't actually. I have a lot of experience in the past of using Dagger 2, and I have very mixed opinions on it. When I used it, it was fairly early in the development of Dagger 2, and it was kind of annoying, especially in multi-module projects. It was kind of a nightmare, to be honest. Not even just from an implementation perspective, but also just from a platform support perspective. But how do you find it? Dagger Hilt specifically. And Joseph asks, could this video be made into a note version? This is something... I'm not exactly sure, Joseph, what you mean by this video. Are you talking about this live stream? Because I did... Oh, I think I know. I guess probably you're talking about what I talked about in this live stream. That would be really difficult because that would require me, like, every hour and a half to 2 hour live stream I do, I have to spend 2 hours making the just the timestamps. And for me to basically turn this entire thing into a notes video, that would probably take me 8 hours, rough estimation. And I would like to do that, but I have a life. And that would be the kind of thing where eventually, if I have the support to hire someone to do something like that, I would do it. But at the moment, I do everything you see here. I write the articles, I write the code, I write the lessons, I set up the live stream, I do a poor job with social media, and that is already so much for me to handle at the same time as learning new technologies and writing production code. So, yeah. Interesting. So I just want to share Gabor's perspective on Dagger and Hilt. So Gabor was using Dagger 2 quite a lot around 2015 to 2017. I had a similar time frame. I started using it in 2016 and used it until about 2018. Yeah, for me it was not really worth the I don't like this word very much, but you hear this word technical debt. But if that word means anything, and I'm not entirely sure what it means, it really did feel like Dagger 2 at that stage was just not really worth the hassle I spent more time trying to get my Dagger components to build than really doing anything else. And I do understand that the whole purpose of the library was to give you compile time errors instead of having to find the errors at runtime. But the configuration and the documentation was just really not great. But it's Gabor says that Hilt is still promising if you're okay with that. And, you know, if it's less configuration and it still works well, then I will absolutely look into it. And apparently it's mandatory pretty much if you're using Jetpack View Model, which is good to know. I don't really use much from the Jetpack libraries anymore, but there are a few things. And Gabor mentions that they've been using a scoped service locator built into Simple Stack for its lifecycle management and state restoration support. And I believe, so is that, so you're using Hilt, or Dagger Hilt, basically to inject a service locator that's scoped? Am I understanding that correctly? Because that's probably how I would use it. I do like the service locator pattern. However, there's a point where if you have like a giant service locator, then you're possibly going to run into issues with memory allocation and stuff like that. But yeah. One final question, and then we will call it a day. So, okay, Gabor's not using Hilt, so interesting. Thank you for sharing the perspective there. So one final question, or comment. Luthier says it would be awesome to have a Discord for this channel or a Slack. I actually have both a Discord and a Slack for this channel. I guess I could share them. I've been pretty underwhelmed by the Discord channel because I had a whole bunch of people ask me to create a Discord channel. And then nobody actually goes on it to talk about things. So, yeah, pretty mixed. I actually, like, a couple times set aside some of my own time for, like, office hours, and no one actually came. So, but that's okay. Let me just find the link for our Slack channel. We do have a fairly active Slack channel with over 250 members, so I'm happy to share that. Let me just find the invite link. And I will paste that in the chat. And it's interesting to hear that Gabor is skipping out on a lot of Android Jetpack stuff too. And again, everything that we say here, at least in my opinion, don't take what experts say for granted if you don't actually understand why they're saying it. I have personal preferences and requirements which lead me to avoid using most of the stuff in Jetpack and to prefer implementing my own solutions. Like, for example, creating my own publisher-subscriber implementation instead of using live data and those sorts of things. But if you're like a professional and you're in a situation or a company where they want you to use the latest libraries and all that kind of stuff, and if that expedites your ability to create working application code, that's not necessarily a bad thing. It's just what I would encourage everyone here is be very careful about anyone who makes really rigid statements like this library sucks, this library is the best thing, should I use libraries all the time, should I never use libraries, developer preferences, project requirements, and experience with the things we're talking about. That is how you establish a setup that works for you. Thank you so much, everybody, for watching. It's been a fun episode. I appreciate everyone who turned out to support me. The YouTube algorithm doesn't really support me at all, but that's okay. I'm going to keep making these videos and doing my best to share what knowledge I have with everyone else and working on the open source projects. Thank you so much, everybody. I hope you all have a great Sunday evening for most of you. I'm going to have a nice, relaxing Sunday afternoon, and that's it for me. Thanks for watching. Auf Wiedersehen.